Hello ladies, in this video we're going to go through section 2F, which is dot plots and stem and leaf plots. So there's not much theory in your booklet for this topic, so I'm going to do a question from your textbook as well. Okay, so if you are fine with the booklet and you want to fast forward to the question, you can, because the booklet isn't that difficult. Okay, let's get started. So dot plots. Basically, the simplest display of numerical data is a dot plot. A dot plot consists of a number line with each data point marked by a dot. When several data points have the same value, the points are stacked on top of each other. Dot plots are a great way for displaying fairly small data sets where the data takes a limited number of values. So, example number 10, constructing a dot plot. So the number of hours worked each day by each of 10 students in their part-time jobs are, so there they are, and here is our box plot. So basically we're going to have a dot for every data point. So 4, so we're going to have a dot there for 4, and then we've got 2 5s, and try to line them up. Okay, so your first point lines up, and then when we have 2 points, they line up as well. How many 6s? 1, 2, 3, 4 6s. Now, the purpose of lining them up just makes it easier to compare, especially if you were looking at the mode. So if you kind of didn't make them even, then it would be a bit hard to see. Okay, and then just 1 for all 7, 8, and 9. Okay, so there's your dot plot. You can clearly see that your mode is 6. You would need to calculate the median, but the median also looks like it's going to be 6. Okay, 6. The median being the middle number, and your mean you would need to calculate, add them all up. But considering that the mode and the median is 6, your mean is likely to be close to 6. But you don't have to do that. The question didn't say it, but just things to observe. All right, stem and leaf plots. So another way of displaying it is a very small data is on a stem and leaf plot. We don't want to have too many values because it just makes things too hard to interpret. So if you had more values, even 50 values would be a lot. You'd probably use a histogram, but in this case we're just focusing on dot plots and stem and leaf plots. So for this one we're going to construct a stem and leaf plot. Okay, first of all we've got here unordered and this one here ordered. Most of the time a stem and leaf plot is going to be ordered. When you create your own, you see how many data values are here. Often you're not asked, well, I'm speaking for a further maths exam point of view, you're not asked to enter in so many values just because it's so time consuming. So often an exam will just get you to enter in maybe 5 or less. Okay, but just to show you quickly how a stem and leaf plot works. So you always have a key, and I don't think there's a key for these. So I'm just going to write the key here. And the key tells us how we're supposed to read our stem and leaf plot. So if you had, and I'm just going to do the number 15, which is the first one here. Okay, so that just tells the reader how to interpret that, because you could have this being 1.5, but in this case it's 15, and it's usually like that. Okay, so when you're putting your values in, we'll just go in order that it's written, and then we can do the ordered ones. So 15, so I'll put the 5 here, 2 goes here, 24. Okay, so notice how I'm only entering in the units column, or the ones, okay, because we've got the 10s here. This is your 0, 10, 20, 30, 40, 50, 60. So when I read this, this is 0, 2, which is 2. 1, 5 is 15. 2, 4 is 24. Okay, so then we'll do 30. So 3, 0 makes 30. And then we've got 25. Now, to separate your numbers, just use a comma. Okay, so notice I've got 2, 4. 24, 2, 5, 25. Next number is 19. Okay, so I'm not writing the number 19 because the 1 is already there. We've got another 24. So even though we've got a 24 there, we include both of them, 33, and so on. So I might just do a few more. I'm not going to do the whole thing. Even if I press pause, I've got, I shouldn't say this, but better things to do with my time. So you get the gist. Okay. So when we're doing the ordered ones, so you can see, let's just do the numbers in there. We'll just do the first few. So I think 2 is the only single digit. And then your 10s, we've got 15, which we've done, 19, which we've done. We've got 2 more 19s. Okay, and I'll just show you up to the 20s. So we've got 24, we've done 25. We did the other 24, 28, another 28, and another 28, a 25, and a 20. Okay, so because it's quite time consuming, I'm just going to order the first 3. So the 10s is already in order, so I don't really have to change anything about that one. But your 20s, we're going to have to put that in order. So the first number was 20. Sometimes it's easy to cross them off as you go, just so you know that you've done it. Okay, I've got 2 24s, a 25, and another 25, and 3 28s. Just making sure I got both 4s there. Okay, and then you would go on to your 30s and so on. Okay, now I think that's it for the booklet. Let's just scroll. Oh, okay, so let's just talk about this. So stem and leaf plots have the advantage of retaining all the information in the data set while achieving a display not unlike that of a histogram. So if I just go back up, and I'll do this when I do question 6, I'll explain how it kind of is similar to a histogram. But you can kind of, if you turned this on its side, and I can't really, well, I probably could, but I'm not going to try to figure it out now on video, how to turn this on its side. And that helps you with the shape. So I'll talk about that when I do question 6. But it's kind of like a histogram. In addition, a stem and leaf plot clearly shows the range of values, where the values are concentrated. So that's where the majority of values are, the shape of the data set, whether there are any gaps in which no values are observed, okay, and any unusual values, so outliers as well. Okay, so there are the questions for 2F, but I just had a look before and I thought, whoops, sorry. Let's just get out of there. Okay, so question 6 I thought was quite a good one, and I might just make that a bit bigger so you can see. Okay, so up to this point, we're just really constructing dot plot or stem and leaf plots. Here we're actually kind of interpreting the stem plot or stem and leaf plot. Okay, you can see here your variable is age, and here is the key. So 1/2 represents 12 years. And it's an ordered stem plot. So most stem plots are ordered. Okay, so it shows the ages in years of people attending a meeting. How many people attended the meeting? Okay, so that just requires us to count. So we've got 1, 2, well, there are easier ways to count than doing that, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, blah, blah. Okay, you can do that. What is the shape of the distribution? So this is what I was talking about with a histogram. Now, because this is in PDF, let me just see if I can rotate it. Okay, oops, I went all the way around, sorry. I didn't want to go, there we go. And now I have to find the question. Did it just skip for me? I think it just went way past the page I was needing. That's annoying. Okay, let's quickly go. Gosh, how annoying for you guys watching that. Sorry, I've just paused it and I didn't realize I was flicking in the wrong direction. Okay, so I've turned it now. It's where I want it to be. So I'm just going to show you, whoops, just wanted to get a color. So our shape, when you think about it like a histogram, if you kind of like squint your eyes, you can see them as columns, okay, even though they're numbers, but it kind of looks like a histogram, and that's what the notes were saying about, you know, it's kind of like a histogram just turned on its side. And often, and I'm talking about further maths here, in the exams, they will ask you for the shape of a stem and leaf plot. And weirdly enough, all I do is turn the page on its side like I am now. And I'm like, well, what is that shape? So this one is symmetrical, but remember, if it goes up like that, so remember in a previous video I said the shape, if you got someone going down a slide, what direction are they going in? This one here is in the positive direction, but if it went like that, they're going down the slide in the negative direction. So those, you know, that's how I remember it. And you think, oh, it's such a simple thing, but don't complicate things. It's just, the shape is, I think, quite straightforward. Now I'm going to rotate my page again. Oh, good. Stayed on question 6. Made it a bit smaller though, so we'll just go bigger. All right, so distribution, it's symmetrical. How many of these people were less than 43 years old? So we look for 43, which is here, less than 43. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so often in further maths exams, they're the types of questions you would get. Sometimes you'll be asked the range. So remember, your range is just your largest number minus your smallest number. So in this case, the largest number is 17 and the smallest number is 2. Hold on. How come that's is the 1? I wonder if that was meant to be a 1, because you wouldn't have someone who was 2 years old attending a meeting. I thought it was funny before having a 12-year-old attend a meeting, but yeah, okay. Anyway, so let's just say 70 minus 2 is 68, so your range is 68. Sometimes you have to work out the median, okay, so remember that's your middle number, or sometimes the interquartile range. But for this case, we don't have to do all that. We just did the shape and the number of people less than 43. Okay, I'm going to stop there so we don't go too long, but please, any problems, just let me know.